That's the first session of the day. Safety Linux versus Safety Linux. Written like this because there's so much confusion around, even after 5 years of ELISA, and it's even getting worse with now all the AI which you can ask. We'll see this later. So Paul and I had a discussion yesterday if we should keep things in or not, but we have a few slides, so take it with a grain of salt, because I just asked large language model what the difference between safe Linux and safety Linux, and how to approach safe Linux, and what do you have to do when you want to come to a safety Linux. So we'll look into this from here. First, a very short recap. We have touched yesterday on the different perspectives on how to approach your project, how, if you want to get Linux into safety application, making use of your safety argument, then you basically have only 3 options, and we all identify that the challenges increase where the complexity increase, and Linux systems are quite complex.
It's worth noticing that these aren't the only options, it's just the options that we've mostly considered. So that, for example, in medical context, you could say open source fits into the idea of software on no problem.
Yeah, that's like the old 1997's one standard which has less rigor and it's accepted.
Yeah,
so
I think some of the down numbers have
yeah.
approach as well.
That's a super, and so that's like this, but I know a bunch of people are in automotive.
Yeah,
that's why
exactly.
we came here and then with these standards. That's good statement, yes. We argued and discussed a little bit about the challenges, but we already know that there are things behaving differently. It doesn't have to say something about if you cannot or can create a safe system. It's basically just something which people first may approach you with and say, well, but what about this? What about these things? And let's just also add the recap in here. Not for too much detail, to just get you on board. So, and now we come, you should always appreciate the author. So I asked Code 3.7 Sonnet, and what you find in the wild on the slide, I hope I cleaned up already a few parts of it, but still it's not everything correct which in this. Let's go on this. What are approaches to use Linux in safety critical system? So the first thing is hypervisor isolation. I think we know this from Electrobit's approach, right? There is the hypervisor underneath. First funny thing directly is it also mentions the safety RTOS, while you can argue if the hypervisor microkernel is actually an RTOS or not, or how you treat this. So this is something to keep in there. So you see there's not direct distinction, and we know that RTOS also plays a crucial role, like for safety monitoring and other parts. That's something which was not put in here. I don't know how I should really treat this, like use Linux for low safety integrity levels. And I mean, the implement freedom from interference, that's something which is clear.
Yeah.
There was actually, I removed some part here where it says like, blah, 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 something, and for higher safety integrity levels, do this and that, and this was totally rubbish. So I was not even willing
I
to
think
put
this phrase probably comes up as a could be used for lower safety integrity levels. So it's kind of like this.
Yeah.
Yeah. So.
Well, that's the risk of the bullet point things, which AI just throws out. You can always double check and ask more questions.
I like this one. Integrate alerts for well-defined certified interfaces.
Yes. And well, we have the argumentation of what certified means.
Yeah, and what's a certified interface?
What's a certified interface? But
certified interface, like EIA meaning? What do you mean by that?
oh, I don't know. So it's real so which said it. But it's not quite
This
as
is the large language model's idea of how to do Linux safely.
Okay, no, makes sense. Makes sense, that doesn't make sense, yeah.
There's a warning that statement up there. You should
You should
have
increase
made
the
red.
You should make that red.
Yeah.
Blink.
And blinking.
red and
Yeah.
blinking.
Yeah.
That's all that way.
I can certainly understand the first approach. I can understand also an FFI argument, but I'm pretty much wondering which is now the, let's say, showstopper requirement when you are crossing the ZIL2 boundary, which is in the end resulting in the statement use Linux for lower safety integrity levels, because from, let's say, a processual perspective and absence of systematic faults and something like this argument, right? We all know this, yeah. I think you will have, even with lower ZIL levels, you have pretty much the same problem.
Yeah.
Therefore, I mean, I would heavily question the middle variant, honestly saying.
Yeah, I guess most likely also on the part that if you find something about Linux, it's often going into SIL 1, SIL 2, or ASIL AB levels from the existing approaches, but you could use it in a higher level system, because there's also like level 4 systems on them driving level 4 parts where Linux is involved, right?
Yeah. Okay, but which of the requirements in let's say ASIL AB versus ASIL D or ZIL 2 versus ZIL 3 makes it now so much easier to say, okay, I can use my Linux for a lower ASIL or ZIL level?
No, nothing.
I would expect so, right? Nothing.
And the biggest thing about this is that we're not actually saying how is Linux involved in these safety applications. And what, the lower safety integrity level, what? If it's again, I think we often have this debate in ELISA. What do we mean by safety? What is safe in this context, and how do we define that? And that's the problem without an actual context that we're talking about, saying what safety means is completely meaningless. But the techniques, the strategies for achieving safety integrity levels, they are common to all of these things, but we don't know what safe is, but we might know what might help us with safety. So I think this is more a statement of intent. It's saying, actually, it's really hard to make a conventional safety integrity claim about Linux. So you should be targeting lower safety integrity levels, but you still have to actually show how you're hitting that.
Sure.
So this is a statement from the wild, fine. However, to be fair, I think it would be good to give a chance to whoever brought these things to justify themselves, in the sense that you found it in the wild, but I hope there was some justification for those. I hope they were not just a bunch of mad people writing things on the internet.
I mean, one part which you also need to be careful directly, and this is something when you start interacting, that there's still a certain that where safety and security are mixed up.
Yes.
And a lot of people speak about safe systems when they actually just mean secure system. While safe system does not imply that it's a safety system, right? That's what's at the topic of what we want to discuss. But in this, like, then they say safe, and if you say it's a safe system, so it's about the safety of the system, and then it's more for intrusion topics. And this is like where I think where the models also can, and where others have.
In Italian, you wouldn't even have the words to differentiate them.
It's the same for German. But the same word for both, that's why we have to distinguish.
So this is a fault of the Germanic leap of languages. It's the German's fault as always. So when they train the LLMs,
It's the English fault for differentiating.
yeah, when you train the LLMs, safety and security go into the same, they belong to the same semantic node.
Yeah.
So, and for me, if you read, none of this makes sense. Even the first thing that you said that it's correct, a certified safety outpost, that doesn't make really sense. This is in a very pedantic and nuanced way, that doesn't make sense. And I'm pretty sure the gentleman in front of me would agree.
He's nodding.
Yeah, so none of this makes sense. And if somebody who we are trying to educate about safety reads those things and take them for granted, we are training people the wrong way. And then you have people, you know, you are training people with this information.
Yeah.
For something that is really critical for people's lives.
Yeah.
So beware of these people that are using it. Yeah, and I think, as somebody said, this slide is very dangerous if you send it like that on the web.
Yeah, put the red.
I put a red caution sign or
Yeah,
let's
because
start with
the LLMs will parse it and they.
and they don't get it, yeah.
You're feeding the disinformation.
Down there.
Yeah, that's like the headlines in a tabloid.
Yeah.
And also real time and safety also get equated.
That's the other thing. It's really like the first thing when you ask for safety to the LLM models, they always come up with real time. It's real time, so it's safety. And you have a lot of use case where you do not even require real.
But I think this one's is a good example as well, is that you very often hear claims about Linux is good at this, and we can demonstrate that Linux is good at this in different contexts. And then you're elaborating after extrapolating from that to say, okay, therefore it must be good at safety because safety requires this. But safety at a formal level is about demonstrating why you can believe that, and anecdotal evidence or even evidence in the wild of it is not the same as I can show that it's safe.
In your argument, maybe what happens is that there is no good documentation in the internet about this,
Mhm.
and the LLMs couldn't find it.
Yeah.
So maybe this is just a gap. And that's something to do with.
I think that's a good point to say. There's missing good documentation
There are many claims, but
Yeah.
not much evidence.
here, and how to differentiate between our marketing pitch and real proper articles, documentation, well, information, what are fake news. Like this one. That's, anyone else wants to add something to this slide? Otherwise, I go to the second provocative slide, which just goes on with implementation strategies. So here we are, real-time extension, that thing.
It's already upstream now too, so
That's
yeah.
why I remark, we know it's
Oh,
no patch
sorry, I didn't see-
anymore.
I didn't see it
I
from
was,
the
I
eye,
wasn't,
maybe.
my head was in front, but
Yeah.
I remember this discussion in Goddard where we had another people and then the guy was presenting all this Linux version and the real-time patch, and Steve Roasted stood up and said, I just want to mention, it's not a patch, it's a configuration, and before starting arguing, I'm the maintainer. Just to let you know. Yeah, and that was done, right? Send on my Arch Linux. I just put in as an example because I haven't read about the name a long time anymore. Certified ready distributions. I removed the ones which were proposed because they were not. Still, I want to buy the Azel Do Linux from Wind River, which was mentioned there. But they couldn't give me any evidence where the information comes. You know, the language model has so many input that they cannot tell you where the source is coming from.
And as Paul mentioned, you should tell to do what.
Yeah, yeah.
The personas too. DeepSeek is I haven't played with this directly, but I heard anecdotally last week. DeepSeek is pretty good about, if you configure it right, telling you your sources for everything.
Yeah. I think there's also,
That's-
we had some models where also more about the sources came in, but
Do that or not?
not always. So
Okay.
sometimes you get sources, sometimes not, and sometimes the sources do not exist anymore.
Oh, okay.
For the safety components, I think implement safety monitors to detect Linux failures. Like that's what I was saying, isn't it?
Yeah.
And deploy watchdog timers and fallback mechanisms is also a general strategy. And memory protection, process isolation is also something which you try to do.
So they both fall in the monitors category for us too. I mean, the idea is the same, monitors.
Yeah, yeah, exactly. But I mean, it's that redundancy is another thing which you use.
The last one,
No, those are more.
not necessarily.
I am told that in functional safety balance, even that can be called monitor.
Okay.
I'm just
Depends
following
on the
here.
strategies.
With the SRU, the tracing an exception.
Yes.
Okay. Industry initiatives. This was the thing that ELISA project was actually mentioned for, which is just logical because it exists for 5 years. And we are delivering safety critical Linux architectures. That's what we are developing. And we're creating tools for certification evidence.
I think we might have said that at one.
And most likely, maybe in the beginning or wherever.
Mission statement even.
I mean, industry initiatives, safety case development, it's not really like, it's more like what you have to do anyway. I don't know what comes in there, and qualify tool chains. I think the heading is not really fitting, but that's how the model made it up. And there were like some other projects, 2 more projects mentioned, which I didn't want to bring in because they were totally wrong.
But this is a good example of you have things that might make sense in the context of a paragraph or a larger thing, but don't stand alone. but also the most worrying thing is that a lot of these things seem plausible to the casual observer, which makes them all the more dangerous.
Okay, I guess this. These were two statements as concluding statements, which were just put out of this question. So, I think this is fair sense in there. So there's trade-offs between functionality, performance, the rigor of safety required for safety certification, and so on. That's a general statement and table, and then also that there are a lot of hybrid approaches for safety certified components rather than certifying the entire Linux kernel. As the certification remains technically challenging and economically demanding, and we know this. I mean, also Red Hat spends quite some engineering resources and going this path. It's not that you say like, oh, we have the 5 engineers and we just go along with it. So it's a significant manpower needed for this kind of activity. I think here I actually asked something like, how do I come to the safety certified thing or whatever? Kernel, or I don't remember, this was just a message. And by this, we were talking a lot like what is the context of the things and what is the use case. You cannot say this, what does it actually mean, safety certified are correct or not. It's really the understanding of the system. Again, what is your use case? How do you want to achieve things, and what is the best path to go? Yeah, we had this yesterday. Just saying again, assessing what the system is safe requires understanding the system sufficiently, know the role of Linux, know the components you use, check for gaps, whatever. It makes sure that you tackle all the risk to a proper level.
And this all depends on what do we mean by safe. We could argue that safe just means we know how it works, we know how it fails.
Yeah.
Rather than it will never hurt people or it will never cause harm.
Exactly.
It means it's safe within, because it has a
Safe
defined.
of the entire, so a little lost in direction of sort of maybe. Yeah.
But then that's why it makes no sense to talk about safe Linux, because safe or from what, or if you haven't actually defined what safe requires in that context, you can't know. So saying that Linux is safe doesn't make sense.
Good, then the safety Linux versus safety Linux. And I would say for safe, the T is needed here because safe Linux doesn't really mean that there's safety involved, but it's like safety Linux. You come to the point where people talk about safety use cases, but actually have a safe Linux, it's most likely that Linux is involved in the system, but does not necessarily hold direct safety responsibility, but supports the safety application as such. Well, then if you come to really safety Linux and use this word, then you most likely talk about safety allocated to Linux. This does not mean that what you read in the wild again follows this pattern, right? And I guess it's then a chance also to say, like, let's try to differ it. Say like, oh, do you have the safe Linux or do you have the safety Linux?
I call this one using Linux safely,
Yeah.
rather than safe, because again, this is where Linux doesn't necessarily have an explicit safety role.
Yeah. But
it is involved. It's providing some support, which is making that possible.
Yeah.
I think Igor in one of our working group discussions called this safety in spite of Linux, which I think is one way of it.
It's conservative way.
Yeah. But wait, the base differentiation and yeah. No, I just want to say something about the A part again, but I guess just as redundancy. From it, ELISA members, sorry if I forgot one of the major members, but I know that these 5 companies have to one or the other extent an evidence on providing Linux solution for safety critical use cases, to one or the other extent, or on the top. Electronics, yeah, right. They also have the parts. Yeah, then I put electronics in this. Yeah. But they're, and then I put like the typical concepts and approaches in there. referring a little bit to the system architecture with the systems workgroup, which we have, which covers not directly everything, but goes along very much the monitoring wire, not monitoring wire hypervisor, but the architecture. And the one thing is like, this is really the safety allocated to Linux, because you have the safety focus within the Linux kernel and part there try to implement this. And still, you may make use of a watchdog because you want to see also that your Linux operating system remains, so you cannot pull yourself on your hair out of the sea, right? If the system starts or whatever, you need to have a chance to detect it, so therefore you still rely on anything on watchdog. I named this one watchdog. Why I put here, for example, an artist, because the more responsibility you give to the Linux system, there's a good chance that you can remove the complexity needed in the other parts. So therefore, eventually, even just a watchdog thing, a clever challenge response watchdog may be enough, and you don't need to full setup. If you then take a Linux system and want to keep it as non-safety, even saying QM already means something different than just a Linux. If you just take a Linux, you put some quality rigor on it because you're building a professional system. So you come to a kind of QM Linux. You may have communication channels like end-to-end protections, you check certain hashes or other parts, and you may do this in the safety certified arches, where you can say, okay, I think there has been something done. And then the safety focus, a lot of things come in here. If you go for a simple use case like with the warning signs in automotive, you can say that you render the telltale, so the responsible thing which is there for safety, like the gear indicator and so on, that you rendered via Linux system, but you can control it via another mechanism and do like read back from the display. So you can do this in the RTOS.
This is where Linux has a function in the system, but you might argue that it's not directly a safety function.
Exactly. And if as soon as you then start to bring back like the read back of the return pass, so to say, like if you do the read back and everything, which is safety responsibility, you bring this in, then you end up here. And that easily. And then the approach is not too much different. You can see if you may require also safety focus parts in the RTOS for this setup. It depends on how the hypervisor is set up, what your system strategy looks like. But for simplification, hope it's oversimplified, we can also set like these kind of monitoring activities in a hypervisor, and then use the hypervisor to control upper layers. And by this, you get more control, maybe more control, or feel like you have more control about the Linux system, more interaction than you would do via parts there. Could also be that you give a responsibility to the RTOS here, but just in a simple case, here's the Linux system, and that's the responsible underneath. What you have, the watchdog for the Linux system in this case, is in the hypervisor. Here you will have a watchdog part, and here's also, so you can really say that the watchdog is an essential element in any of these setups.
But I think you can also see that, you know, even with these simplified models of the ways in which Linux might be involved, it's still not really very clear. There's still a lot of nuance and possibility of variations even within these individual models.
Just want to make a comment that besides the more technical aspect, there's also the licensing aspect, where when you start to monitor Linux components like metadata and so on, then you need to know the layout of this stuff. So at that point, you start to have to integrate in your external component parts of the code which is managing them. And then it becomes fun, because if your RTOS or hypervisor is closed source, then you cannot do that, even if in theory it would be possible. Or you can do it, but then you have to relicense it. So there's also that angle.
And if you touch this angle, it's not directly related to the safety topic, but we see that there's a strong interest in using Linux for safety critical applications or in the safety critical space. And why you do so is because of the wide adoption of Linux. You have such a strong ecosystem, so many developers out there, expertise and so on. which you gain in there, and you can basically literally deploy it to any kind of hardware setup from small scale to large scale, and everything is possible with Linux. And that makes it attractive to use it, depending on which kind of RTOS you choose, or depending on which kind of hypervisor you use. You may bring yourself in a situation where you are exactly where you are. Not for the interaction between the two parts, but what about the maintenance? What about transferring it to a new architecture? If you have, we saw it with the AGL SDV example where it already says then or other hypervisor, because Zen may not be supported on every architecture or on every SoC properly, or it's supported but or principally running but not fully executable, misses features. Same thing holds true for other ones. Could be, I don't know, there's a Ganya hypervisor from Qualcomm, which is basically for Qualcomm. There's an Acorn hypervisor for x86 architectures. There's CanConcept one, and it may not be all running on all. These are all still open source ones, right?
And also there's a kind of a hidden aspect on this, which is that in all cases, we've got some hardware layer at the bottom, and there's an integration aspect between that, and where Linux, even if Linux doesn't have an explicit safety role, it's still integrated with the hardware. So there's still a level of additional consideration that you have there. If you've got a safe hardware, does that make the Linux safe?
No. Yes, it's yeah. And therefore, I think it's quite good for the next session also, which goes there in the
other way around. Don't have a safe hardware. Doesn't matter if you have a safe thing.
That's first. That's an arguable
So
point.
if we argue that safe Linux is a nonsense, is a safe hardware also a nonsense if you don't know
So-
what you mean by safe?
We're talking determinism here, are we? I say the hardware.
No, I was not for determinism is something that is very hard claim to make.
I know, but then how talk about,
So it's more like a political claim
okay.
that that you can, for which you can make a lot of testing and tuning to what the end user of a watch knows. Basically, what I was trying to say is that if you don't have a safety qualified microprocessor and system memory management unit, then you can't run anything safe on top, because at the end of the day, you can't rely on the hardware. That is what I was hinting to.
And similar would be, I mean, you can, it's maybe also one aspect why other solutions go into this field. Still, even then you would most likely go on the microcontroller scale and would say, okay, I need to have certain trust in the microcontroller area that it will detect the things which has and will run and make sure that my scheduling works, and that it see a watchdog being triggered properly. And this, you need to have certain trust or guarantees or whatever it comes from. And this is most likely that what you say was certified hardware or safe.
But even
But for this one here, what we
don't need to have.
don't need to have safe hardware, do we? Because there's no
you
safety.
need to have
Yeah.
a safe microcontroller.
Yeah.
Not just the watch.
Yeah.
All the microcontroller.
Yeah, but usually it's called safety island in the sense that
We're not stealing anything from your discussion right here.
No, I think to the point of Gav, you have a good example. Right now, when you look at the avionics market, you have a lot of aircraft that are currently running networking processes. So you cannot call them anything safe or not. And that's also the point of Gab and Paul. You need to build your trust. So in fact, in the end, calling something safe is ambiguous. You need to know the hardware and the software you are using for the use case you have, and know what are the failure modes that can be there. And you build the overall system on top of this to be safe.
And I think that's the thing, is sometimes there's this equation between safe means this predictability, understandability, certain reliability. But then somebody hearing the word safe takes a different meaning. They think it means, it absolutely won't hurt me. No, it means I understand how it will fail, and therefore I can build a system that is safe on top of it. And this, I think, is it's this, we talked about security and safety meaning the same thing in different languages. I think that's the other thing, is safe can mean lots of different things in English.
Daniel.
Just to change a little bit the perspective, because we are looking at one processor, right? The safety in Linux is managed in the railway sector, it's achieved by redundancy and diverse architectures. So we should not keep the focus. There are systems where Linux can have safety focus and still not be reliable on it working completely in one process. It's watched by other diverse architectures or things like it. So that you can build a solution around that.
Yep.
Like the complete system, you just have to have more power than you might have in a car.
Which is,
But even in automotive, you can have
redundant.
Yeah, so in railway, it's very useful to 2 out of 3, and then you really don't care about the hardware. You take out of the shelf hardware and say, we make a redundancy out of that, and do diversity and do some checks, and then we build everything around, and then it doesn't really matter that the hardware is safe.
I also had similar discussion on automotive, and you bring a fair point on this. What happened was we were discussing about level 2 autonomous driving or ADAS level 2. I was like, okay, you can build this, that's fit for, it's potentially fit for using Linux in there and so on. So this was a discussion going on. And then he said, what about level 3? No, this will not work. And then it's not possible to do it for level 3. And why? Why was, and we discussed it around and then said, but I know about approaches to go to level 4 with Linux. And then the answer was, oh yes, that's no problem. What? You can say I can do level 2, I can do level 4, I cannot do level 3. Why you cannot do that? It's too expensive. Right. That's a completely different point. You want to create your level 3 system with a single set of hardware, and that because you want to target a market region where it's price sensitive, and that's why you cannot do it. And that's the wrong assumption on it, right? It's like you can do, if you can do level 4, and why shouldn't you do level 3? Yeah, it's just a product thing. But that's also when you talk to people where it's really like narrow set of scene, and then you hear a lot of like level 3 will not work because they need to be fail operational, and fail operational is not possible with the single processor architecture when you use Linux or whatever.
We're thinking about single box models. Whereas actually, if you've got a small enough unit and they're cheap enough, then having multiple cheaper things with redundancy might actually be safer.
But it's independent on whether you use Linux or also so
exactly. And that's the other thing. You could use Linux and something else in a kind of a redundant pairing.
I think the 2 out of 3 thing I will add here. I will not make a complete drawing, but I will make a comment there because it's really
just to show that there is another.
That's good.
But usually we don't talk much about it, the 2 out of 3 thing, like it's come to handle hardware failures. Usually, because if you use the same software, that doesn't really help. That's where dissimilar system, the dissimilarity is the one to handle both. So that's why usually when we talk about software, sometimes we don't bring this aspect because it starts to be more system view.
When it's a redundant thing, but where you've actually got Linux performing a function that you might have in one operational mode, and if you then have doubt that Linux is able to do it, then you kind of have a fallback system, then that might be viable. But that would be 2 different roles rather
dissimilar.
It depends also on your interference model, because, for example, if you're doing a randomization of the base image, then you can kind of claim that it's unlikely that the same fault will happen in software in 2 instances identically. There, even if you have similar software, it's unlikely that they both fail in lockstep.
And the thing is, they will also they may even, and they will fail because of the same error in the code, but most likely will not fail at the identical time. That's really the same. Okay. Oh. You muted. Sorry. You're good. Okay. Well, it's just like that's what you sometimes heard that Linux is not deterministic and you cannot rely on what's going on there. And then you say, okay, then I build a 2 out of 3 and I run 3 identical. No, well, that's identical. They will fail at the same way. So at the one moment you tell me it's not deterministic, and the next moment you tell me they will fail at the identical time. But again, you need to understand how you use it, how you configure it. Will it run on the same architecture? Will it run on will it be the same compilation? Do you change certain things, configuration? What are your measures? All the things you can touch on. I mean, we were looking for weeks to find a black screen or flickering a reset in the system. Which was not reproducible, and we saw it. It has happened in the logs. It was really taking us a very long time to figure it out. And then even if you just start to instrument the code or anything, if you change the behavior, so if you just add a log message, you have a completely different behavior. So we may never be able to trace down where you are. So this is like can be super complicated. Just find a flickering on a screen from a GPU card or so.
Well, adding log message is what we fix.
Yeah. I once was debugging a system which always worked. It was just a new release on some certain on the Linux system, and then my video decoding didn't work anymore. And after a week, I figured out I had to swap 2 instructions. And when I swapped them, everything was fine again. Well, I don't remember exactly what it was. I was just like super happy that I analyzed what has changed, what could go wrong, what was, and then like
2 instructions.
and it was just like changing 2 instructions, like, okay, now it works again. There was a timing thing which before never happened, and it was just like by accident that I found it, and these things happen. So this makes strong. Okay, anything to add? No.
I think this emphasizes that if you don't know your system architecture, you've got a starting point.
Yeah.
Which for me always is the question is if it's so system architecture dependent, what can we do? What common things, what common aspects can we focus on? And then it becomes not about safety, but understanding.
Yeah.
Knowing what's going into your system, knowing the aspects of the software, knowing the ways it can fail. Because then when you are doing your safety analysis for the system, you can then actually have the inputs to understand that and define what safe means.
And there, with this configuration, and like we have the real-time parts in there, I heard from a bunch of colleagues which said like for the use cases they are having, they change a few parts in the scheduler and they get better and or comparable results to proprietary certified OSs, and for the use case it works sufficiently and they do not even need real-time patches and come to close enough to what they need as real-time, because real-time is also a very changing thing. So, and there's others which say as soon as you have an RTOS involved, you have no real-time anymore, because for them it's really just like bare metal execution on hardware, otherwise it's no real-time. So these kind of things fall into the concept. Here, this is like the external watchdogs part, this because it's everywhere and something to look at. And I think the main point is it's really your safety net. And in best case, with a proper system design, the watchdog never gets triggered. Which is like, we could also say what's the proper system design. It means none of you did it forward, right? That's why the watchdog is not triggered. It's really, if you do the things right, you trigger it. It's your safety net, but it's not the intended end. If this would be triggered, it very much soon becomes a user experience issue. So most likely this will be someone say, okay, so imagine your instrument cluster in the car and you have every 5 minutes, it will turn into the safe state, make a black screen, reboot, and then you have it again. Safety wise, perfectly fine. Mechanisms are triggered, but it's nothing which you really have managed on, even if everything from the safety perspective is met, all your assumptions and goals, but the user experience is not there and it's not the intended function. So it should run longer than this time.
But again, depending on the actual function, that could be really undesirable. So
yeah,
incorrect triggering of the watchdog could be unsafe in itself.
Yeah. And then I put in the past part of the EGAS monitoring concept because that's something which you see as a repeating pattern.
So that's an established pattern for solving a particular safety problem using a watchdog, and it's quite useful as an illustration.
Yeah.
Good.
Yeah, this was just on the, because we are at Volvo, I saw like just bringing some parts. Because people say it's not there, and from what I saw, there's the rear view camera, I see instrument cluster warnings, then electronic mirrors which go in a similar like rear view camera use case, surround view parts, so where cameras are involved. These are things which have an ASIL rating, I would say, and are in the wild. You can find them in cars being used. Interior monitoring is something currently we heard also from Magna in the discussions they presented last year here, that they developed these kind of things. And it's actually not too much different to what we have here. So you also analyze these parts. We know that there are ADAS level 2 systems, level 2 plus with highway pilots and whatever are already out there. In Asia, some other from US companies. And this is currently more like where traditional OEMs may not directly look into. So they wouldn't bring this, so this is more like the front runners of it. And everything, there is a move there into this field, so it will just become the new normal. And then if you see on the under development part, there are level 4 systems under development on the way to production, utilizing Linux, giving responsibility in there. So that's more the aggressive part. And this will also go there. And here we have the ADAS level 4 to 3 thing. That's why they just put like for the future, will we have it somewhere in now 3? It's just a cost driver thing, right? It's just if someone takes it, brings in, that's there.
Some of these are good examples for the rear view camera. If Linux is responsible for displaying the image, what is its safety function? Is that a convenience function or a safety function?
Yeah. And especially you do not even need the rear view camera or a rear view. It's
You
not
don't have to
mandatory.
look over your shoulder. So.
Yeah.
Yeah, one question, like, what's preventing, is it the easy level of Linux? Like, if hypothetically, we would have an ASIL D Linux, would that unblock the L3? Or what is the blocker for the L3 deployment?
I would say from all the aspects which I saw so far, there are hardly level 3 systems out there. And everybody, they talk about level 2, level 2 plus, level 2 plus plus, and so on. They come to different levels. So they always try to avoid to come to the level 3 hands-off driving. And because, I mean, at this point, you always, whenever you say, you can always say, the driver has to have the hands on the steering wheel all the time. And that's something changing here. And maybe then it's a responsibility shift, which is more the level 3 thing, why people don't come to level 3 and you bring more into the level 4 plus because you have different use cases and say like, okay, we are accepting this as some part. It's a different level of systems. We maybe bring it into commercial vehicle trucks and so on, where we replace driver for hub-to-hub transportation or other parts, just hybrid parts. So I believe this is not, from all I learned, and we have automotive people in here, but for me, it's the level 3 is less. The Linux also with an ASIL D Linux. People haven't made it yet, wouldn't directly made it, I assume. Just a pure assumption. Philipp's view, so not. I don't know if anyone else has a view on this. Yeah, that's the last slide, so we can get into discussion on this. We already started. I don't know if there's something we fundamentally missed. Something we need to add. We have half an hour left on this one. Anything in the chat, maybe?
There's nothing in the chat at this point. I'll type in.
So does anyone still think there's some ambiguity about how we use the word safe and safety? Is that clear enough?
People think
what I would miss then, I think you should state that difference very explicitly in a definition. That I missed in the slides.
Yeah.
You make,
Yeah.
so we talked about it now. Make the definition what you say, it's a safety net, not a safety net. And write it down as it, because then you get it very explicit.
Oh, yeah, more than the just to,
Yes,
yeah, like the real.
make a definition of it, right?
Yeah.
Something to add to the directory.
Yeah, it's just that the directory thing, we can put slides into the directory.
The
Same
citation
minutes.
can be found.
Yes,
Make it
exactly.
fun.
Yeah, by a search engine.
By a search engine, exactly.
Yeah, the slides can't be found by search engines.
The PDF files on the directory. maybe.
Long time, long time.
I have a question, and you mentioned understanding, it's important when it comes to safety. And I listened on the talk, Daniel Stenberg, author behind code, is a single person, 200,000 line of code.
Yes.
He stands for 50% of the commits. So I assume he understand the code base.
Yes.
Your challenge here is you compete with 30 million lines of code in the language kernel. Of course, we have hypervisors and lot of imports, but how do we address that issue?
That's a really good question. So if safety depends on understanding and we have that huge volume of things to understand, what hope do we have? I mean, again, if your understanding has to come from the code, then yes, you have a problem there because
But what you also need to bring in, like for these very million lines of code, you should check how much is in the drivers, in the different hardware supports and so on. So you will also reduce a lot of code already by this.
Yeah.
Reducing the different architectures which you don't need will also throw, and there's still a lot of things.
there's still a lot of code.
Yeah.
Yeah, and there's a lot of people who have that code. Have you gone and looked at the Cregit work yet? No, or no? CREGIT? Cregit.linuxsources.org. And you can see where all the code is.
Mm.
And then if you can go into the directories, you can see who's participated in each of the files. And you can see we can actually have pretty good precision about actually knowing who's actually changed something and why. When you start looking at the commit messages and what's actually there.
But that gives you an understanding of an individual change or a series of
It
changes.
gives, yeah.
It doesn't give you an understanding of the system as a whole, the
documentation.
software as a whole.
So, yeah.
And the documentation in the Linux kernel, there's a lot of documentation. And some of it's really excellent documentation, but it's often hard to find the particular bit of documentation that you need. And also some aspect, what gets documented and when and by whom varies a lot as well. So there's not homogeneity between the thing. You don't have a kind of consistent level of either depth or up to dateness in the documentation. And that is one of the huge challenges. If you need to understand this very complex system, and actually your best way of understanding it is to look at the code, then that is
And you need supporting tools as well. I mean, it's also that you can say, like Alessandro and the Linux features, you created like a minimal application and just check like which subsystems are involved, what do we really need? We had the surprising part about the touch-up power where you say, okay, here's like randomization needed for shifting, which was security feature by default to just change the load address, which had actually impact on the memory allocation page table and so on, where you had shifts. And this is some element, but you can see, okay, these are subsystems which will be always there. So definitely it makes sense to have your understanding, or it's not part of your argumentation or anything. And you can say, it depends, like, what do you want to achieve? But then you can say this something, and then you can start using Cregit and say, what's the change rate in these parts? Or you use other models to just like say, what has happened or so. You can create data, you can make assumptions or checks on these kind of things and just approach things step by step. Still, it's a super huge thing to look at.
Nowadays, my feeling is, I mean, the overhead of searching stuff for me has decreased a lot, because you can just go to almost any AI and say, I want to know which function does this. And you get an answer. It might not be correct because maybe it's about some older version where you can go to Bootlin, Elixir, or Cregit, or whatever, and verify. But at least it saves you all the time of trying to figure out.
And that's the important part is what you mentioned, is then do the second step and not only ask for it, say like ask for it and then cross-check your answer, right? And
You don't have to read the code, at least
Yeah.
you know which to read.
And that's the point, that you're right, actually navigating, finding things in the code, being able to engage with the code has got a great deal easier. So it is,
Yeah.
it's totally possible
The
to do that.
difference is that in the past, you would have to start begging for information on a mail list, and maybe some guy would reply to you after a week. Here you can get in a matter of minutes. So that's the difference.
Graph is your friend.
If you don't want to graph, you know.
Yeah, and it's really like data becomes accessible and information becomes accessible. And you can learn a lot of things. You just need to always take it with a grain of salt and double check and make sure that it's not totally rubbish for like,
Yeah.
To a lot of extents, it's like the AI is your super motivated 24/7 intern.
Yeah.
Right? Fresh from university, comes with all the coding skills and everything you could imagine, but
None of the experience.
misses a lot of the experience, then it comes more to the 3 years old child, right? And then we have the wrong feeding of information, which we discussed, but like for looking, it's really, I think it's super helpful.
I have, my experience is, I agree that it's very easy to find code using AI tools and get explanations, summaries and everything, but you miss all the pain as you described. It's to reach that point, you know, and we as humans are more equipped to learn the struggle and suffering than, you know.
I think I get enough even with the AI.
No,
Strong objections on that.
it's also worth noting that actually the documentation for Linux from a user perspective, if you're actually looking at trying to use a given syscall or a given command that's backed by a syscall, is really excellent. It's, you know, it's grown and developed and kept pace with it, and also because that interface has been relatively stable, that documentation is really good. But again, it doesn't necessarily tell you how to use it. It tells you what commands are available, what options are available on a command, and that can be a really useful input to your understanding, but it doesn't necessarily give you the whole picture. And importantly, it doesn't give you the picture of what's happening behind it. It doesn't allow you to engage with the way the kernel itself is designed and architected, only how you can use it and what you can expect from that. And to a certain extent, this is, I was going to say by design, but it's, you know, it's a kind of an acknowledged feature that you don't want to constrain the way the internal kernel is designed as much, because you're trying to preserve that external.
I think this is because there are two different communities of users of
Yes.
Linux that, you know, would read the man page or the Linux administration guide.
Yeah.
And they don't have a clue about how the kernel is written, right? And then there is the community of developers that instead mainly modify the code by reading the code. Mainly. So, but yeah, now here is that we need to improve the documentation about the Linux internals to achieve say like intrinsic
To achieve
safety.
understanding.
To achieve understanding, that is the baseline for an intrinsic safety claim.
And if you take the Safe Systems microconference at Plumbers last year,
Yeah.
where we actually had Thomas, Stephen, Jonathan in the room, and where Thomas also made a statement, Thomas Flaxner, like, we need to work more and resolve this technical debt on documentation paths and so on to make the Linux kernel sustainable for the next 20 to 30 years, like we have had for the last 30 years. Because what you also bring in was like, with all the million lines of code which are being maintained by people, there need to be a point in time where another person is able to pick up parts of this, because there is a generation change coming. We don't want to see it, but there's just something, people come into an age where they may want to change something or may leave, and so we need to, and this will, even if they don't want to face it now, it will happen somewhere in the next 20 to 30 years, just naturally.
So is the answer here to actually back away from using the word safety when we're engaging with the community, to say, actually, you know, what you want is this to aid understanding, to aid
Well, I think that
sustainability?
was why we called the microconference safe usage of Linux,
Yeah.
right?
What safe use or safe system? I don't know.
It was safe usage.
Yeah, safe use of Linux, yeah.
Could you have a different level of understanding? I mean, the core, the hypervisor, probably more critical from a safety standpoint. And then you have the application running in on top of the hypervisor. I mean, like a smartphone, you have an app. You have a good isolation.
So I think that's taking us into a place where it's a judgment. And how do you come up with an objective judgment? It's like, you know, the trustable system is a way of potentially coming up with an objective judgment, or at least that's part of the theory that I've understood anyhow. We'll have more discussions on that tomorrow.
Right.
But the question is, how does one qualify that? And then make it such that one has built it up. And I don't think we've got a good system completely yet here for that.
I think there is also another problem because there are the evolution of the safety use cases require a complex operating system like Linux that is also able to handle, you know, like a graphic stack. I think there are certain use cases that you just cannot, you know, that you can not satisfy by using like a bare metal code running on top of a hypervisor or even an application running on top of a simple operating system like Zephyr. So there are certain use cases that require like a complex operating system.
I think what you're saying though is that actually engaging with and understanding a system use case first, and then saying what the implications are for Linux as, I mean, describing Linux as an application might kind of make people struggle with the concept, but the idea that I'm providing some level of safety or some level of rigor around it, and then it reduces the burden of understanding. So I'm not sure that's really necessarily going to help, because you still have this incredibly complex thing you need to understand.
Like I said, when we were doing the open APS system, when we were analyzing it, we knew exactly what the system was looking for from Linux. It was pretty basic. You know, it was basically interfacing to the hardware and providing certain pieces of information through the stacks. So we can get to that level and then look at those paths.
So if you can reduce what Linux is doing to something very simple, then yeah, you're right, that gives you a very directed path through. You can focus exactly on those areas and branch out from those to see what might be impacted by those. But unless you've kind of got all those inputs and interactions in down, it's very hard to do that.
And that's part of the why we did there's a white paper about running traces on parts that was motivated by that.
Yes.
And we actually got we put some upstream documentation into the kernel so that people could know how to do it.
So the strategy there was using a methodology called STPA to describe at a high level what the kind of the larger system needed and how Linux was involved in it. And then having identified what those interactions were, to then do this tracing within Linux to say where does that path actually take us in the kernel, what other subsystems are involved. You can start to build a picture. So understanding can then come from analysis. You can reduce the complete set of things you need to engage with steadily, but you still then need some good guides to those areas. But maybe that's you know, one way to start to eat this elephant, chop it up into smaller pieces, identify the things that are always involved, always part of a system, or very likely to be part of a system, and build out from there. Because those are also likely to be, in many cases, the more stable parts, the bits where actually we could have design documentation in the kernel that remain the same and was accurate.
Igor, you were looking like you want to ask?
Yes, I have a question. I'm aware of the work that is going on, so got to add documentation to the kernel and testing, and that's great. It's a step in the right direction. However, that's not really patching code. What I would like to understand is if there is a vision about introducing or trying to introduce features which are safety oriented. Because if I look at the history of how something close enough security is going, there has been this constant tug of war between performance and security. And if you look at the average reply that Linus writes to Case Book, that's not something that I would like to be seen written at me. So in that sense, you need to have someone who's willing to go and push.
I think I can answer this. So first of all, so the thing is, if you, I mean, I'm the lead of the safety architecture working group, and the working group was born with the goal of analyzing the, you know, the Linux kernel, and probably starting from the most critical functionalities, like for example, memory subsystem, right? And the idea was, while doing so, eventually also, you know, proposing implementation of safety mechanism of features that, you know, that would increase the safety. The problem was that we found a gap in the documentation, so it was really hard, you know, to support safety analysis and to scale it eventually. And this is the reason why, you know, now we are focusing to build the documentation baseline first, and then also moving, you know, to safety analysis based, you know, on this documentation, on this understanding of the code. But the key, so this, yeah, so this is, so in my opinion, yes, you know, we can have this in the future, yes.
The patching of code.
Patching of code to introduce features that could increase architecturally the safety.
Yeah, and I mean, that's great.
And we have already that, I mean, the security, if you look at the security features, there are features that, you know.
That's the key. If you can show, here's a vulnerability, here's the consequence of this, here's why you want to do it, then you can make a case for why that needs to change. But if you haven't got the understanding, the ability to do that.
But if you're familiar with the GR security folks, okay, that's a bit different story, but I mean, they went a very orthogonal direction. They had any sort of licensing issue that's the scope of this discussion, but they basically kind of have kind of like the RT patch, but with no wheel or merging back. So that's something that I'm afraid might emerge, that you have this safety Linux, which doesn't.
But this is the reason why we are trying to onboard all the maintainers. We talked to Thomas Glexner, Jonathan Corbett, and Steven Rosted, and some others.
And actually Greg's interested now too,
Yeah.
so.
Yeah, my fear is that as long as it's about documentation, they're fine. But the moment you start to touch performance, they
That's
might react differently.
Questioning
One
point
step
is,
at a time.
Well, I think it's similar, it will end up similar like with the RT patch. Not patch, right?
Okay.
So I watched this over the years. So it was always, yeah, we'll merge this piece. But in the end, the pushback came from more or less from the server guys, right? Okay. But once the patch made it in, or pieces, yeah, also the server side had a benefit from it. It might take time, as with RT Linux, right? But in the end, that's what I saw. Also, the guys that were opposed to it had a benefit.
and I mean, that's the point which we anyway want to take, because the things approaching for safety or improving safety, however you do it, it should benefit the wider kernel community, right? And like improved documentation, also like we introduce requirements and tests. So it's something which is a new thing, and it supports us, it helps us, improves readability, you can understand parts of it. So it adds value, but it adds value also to a wider community, hopefully, and not only to the safety people. And I'm pretty sure that those safety things can also help to be more robust, reliable, redundant.
Yeah, but think about, I mean, the difference I think is that in the server case, you have pretty tight upgrade cycle of software releases. But imagine how many cars will be manufactured out of forks during 10 years, assuming that it takes half the time than the RT patch to get merged. So you will have this.
So maybe you're right, maybe you do actually need a kind of a long-lived fork,
Yeah.
which will upstream aspects of it over time.
We don't, I mean, like, I can tell you, I mean, from Red Hat perspective, right? So Red Hat has been maintaining the both the non-RT and the RT patch set kernel together in the release.
Yeah,
So
that's fine for that, but I was asking because ELISA says that we do not want to have a fork, but maybe.
ideally,
No,
mean,
so
the
we
fork is
can't,
more
we
difficult.
we can't maintain a fork.
Yeah.
So that doesn't mean a fork couldn't exist.
Yeah, depends whether the commercial interests are there or not,
yeah,
realistically at the end of the day. But part of the reason it took so long to get preempt RT upstream is the way it was done was replacing components with things that were perceived as better by the entire community. Okay, and that's why it took 8 years. Okay, and like it was like the last 2 years was all about print K at the end of the day. And we needed it for full system, okay, and then once it was there, we could finally have the option turned on. And I think documenting what is there and making it explicit, which we're starting to do with quote unquote requirements, effectively and being explicit, is making people think about things properly
Yes.
and giving us a forum for creating the testing to actually prove it and keep it more reliable going forward.
yeah. So in my opinion, I mean, documentation and testing do not require a fork. When it comes, so then if you say, but if I want to implement safety features, right? Then do I need a fork? I don't know. I mean, we can evaluate later, but it's like one step at a time. It's otherwise.
But if the challenge is it's a trade-off between security, performance, and safety, pick one, pick three. Then yeah, you're right. In some cases, maybe you actually need a configuration which says, okay, if actually safety is more important than performance to you, then operate this way.
That's why we have the configs, but
Exactly. It's you know it's so in that sense it should be a solved problem, but the missing piece is the understanding and the appreciation of why these things are needed. And I think that's one of the things that the RT adventure illustrates is that there will have been a great deal of understanding of the system and how all these things.
mind you, we're still missing the documentation for RT. The formal F-level documentation is still a frustration point for me.
Well, exactly, but also there's an understanding of the system that will happen through looking at where all these touch points are, which won't have been captured anyway. It'll exist in somebody's head or a few people's head. Finding a way to bring that, making it easy for people to encapsulate that understanding, make it available to a wider audience. If we could do anything, it would be, again, we can't go through and document all the kernel.
So,
Right, but we could make it possible for the much wider community to do that, and that would be really, really valuable.
Yeah, and Matt comments from online and 100%. The existing requirements and doc improvements can inform the suggested simplification for safety.
Yes, to add to that,
Yeah.
what's interesting with, like, if you look at aerospace, a lot of it is just producing the artifacts such that you understand where you have the complexities and how they interplay for like interference with other things. So getting those artifacts in place for sure will allow us to tackle like the really hard topics like dynamic memory allocation, the way applications are linked, and the way paging and some of the things that Linux does to just normally, and just to key on that minimal application has a huge purpose and maybe gives us that direction of where to focus first.
I guess. Like 5 minutes left more or less from the session.
What are the takeaways from this? I mean, I think
The few takeaways
definition of safe and safety, I think,
is something we
useful.
Yeah, then make a very big disclaimer or somehow
Don't-
make it. They're not possible by AI that it get the wrong impression of it.
Yeah.
So really makes it like misunderstandings around things. Or something like this, so that we just clear this out. We bring in the 2 out of 3 part on top of it.
Differences.
We add some definitions then to the directory, also what safe Linux and safety Linux mean. From the architectures, we basically covered those which are there and which are the typical approaches. We focused a lot on the automotive industry and then took the wider picture. That's something to mention there.
So your 3 architecture diagrams, for example, where do they exist?
I mean, the overall architecture exists in multiple industries, especially also the.
No, I really meant do we have that in somewhere that somebody can find it?
It's actually in the systems workgroup repo.
Okay.
But the thing is that it's there as a picture,
Yes.
which means it's not properly possible.
Okay.
There you go. So we can document this also.
Yeah,
And-
and we could turn that into something that people could interact with, improve, add suggestions, add new versions,
And
that would be helpful.
What actually could make sense is to write these things which we discussed, not only in presentation, to rewrite this down as an article. And bring this then forward with the input there. Yes, we will have some volunteers to read through that we are really taking the right things there. And we can draft something out of this, and I think this will then add value, and then you can just point and say, here's the article this describes, and you see that you'll find that these are also in searches, and then if you can find this there as a link, then you can. And we can act as like, use as explanation project, which tells you like this is there, and you can judge this as a glossary term and say, okay, here's the definition of this. This will help bring us forward. And basically this is like what I really like. This was a draft set of slides, and we had very good discussion and good feedback, which can end up in a work product and a small little result, which we can later on publish to the wider people and promote this. And this is the idea here to bring forward. So it's really great. Cool. I guess for this,
Great.
we can stop the recording first.
Yep.